Hi, and welcome to the second tutorial about CODAP. Let's take a look at some key functions in CODAP that allow us to explore data in a visual way. There are so many questions you could ask and wonder about regarding heavy metals in osprey chick blood samples in the Upper Clark Fork watershed. To begin this tool demonstration, I will first come up with a question of my own that I want to investigate. I'm pretty curious about how copper levels have changed over time from the years 2006 to 2019 in the osprey chicks that were sampled. Specifically, in Missoula, here's Missoula, compared to the Warm Springs Pond location, which is closer to Butte. There are a couple of ways to isolate data in specific locations that I'm going to show you. Let's first start with the map. First, if you look at the right-hand corner of the screen on the map, you'll see that there is a white square with a dashed box inside. If you click on this tool, it will allow you to isolate and see just the data points in the Missoula location, for example. Let's click and drag. It will highlight it blue. And if you also come over to the table, you'll see that the corresponding data points within that Missoula location are also highlighted blue. This allows you to focus on one area at a time, and you could do this for each separate location. To go a step further, if we want to just focus on this and not have all of this background data show up, what you're going to do is click the eye icon on the table and say set aside unselected cases. This will allow you to just view all of the data points within this one specific location. On the flip side, if you want to get all of the data back to how it originally was, you click the eye icon and you say restore set aside cases, and everything will repopulate. The second way to isolate data and view it visually is by making a graph. On the left-hand corner of the screen, you'll see a bunch of options that CODAP has, but we're going to really focus in on this graph icon. If you click on it, a blank screen will appear. It's worth noting that you can enlarge or make smaller any screen on CODAP. So I'm actually going to make the map a little smaller here and make this graph screen bigger. On the graphing function, you'll see that it says click here or drag an attribute on the side as well as the bottom. Attributes are just what we called in the last video our columns of data. So location, year, and all of our 7 heavy metals collected from the osprey chick blood. Focusing back on my question of interest, how copper levels have changed over time, specifically in Missoula and Warm Springs, what attributes do you think I would pull first? For me, what I think I'm going to do is put the year on the x-axis. So you click, hold, and drag and release, and it self-populates. The metal of interest that I was curious about was copper. So I'm going to click and drag and pull that to the y-axis. You'll see that CODAP is amazing, and it already feeds this data into a graph. It's also worth noting that we need all of our parameters, so the attributes that we've pulled, to be numerical. If you click on the title of the y-axis, in this case it's copper, you'll see that there's on the bottom treat as categorical. So we're already being treated as numerical. Same with the year. All right, so yep, we're both being treated as numerical. The only attribute that you would ever want to treat as categorical is your location. So, thinking back to my question, I had 2 very specific locations that I was curious about. Missoula, and let me get this map back up here. Missoula compared to Warm Springs Pond. When I look at this graph, I don't see that location is denoted. It has the year, so over time, and the copper amounts in microgram per liter, but it doesn't tell me what location these points correspond to. This is where CODAP is pretty amazing because I can actually drag a third attribute over to my graph. In this case, I'm curious about location. I'm going to click and drag. And for this third attribute, you're going to want to put it right over the center. You'll see that the data points become colored and they correspond with this table. So you could spend time examining all locations, understanding the copper trend over time. I'll just show you this fast too. Now that we have our locations denoted, you can actually pull a different heavy metal right onto the y-axis. So let's take zinc, for example. If I take zinc and replace copper with zinc, it will shift it around. But I'm going to focus back on copper here because that's my question that I'm curious. So let's go a step further. This is great now that I know the data points that are corresponding with the different locations. But again, I'm interested in Warm Springs Pond in orange and Missoula in red. To isolate this even further, what you're going to do is hold down the Shift key on your keyboard and select the locations that you are curious about, whether that's 1, 2, 3, etc. You then click on the eye icon on the graph and you say hide unselected cases. Amazing. So you can see now I'm just working with the two locations I'm curious about. Missoula, which is actually outside of the Upper Clark Fork watershed and downstream, and Warm Springs, which is closer to Butte and had a more heavy impact from the unregulated mining that happened historically. Right away, I'm noticing some curious things about my question. This point right here, for example, there's no other points around it. And this is telling me that in the year 2013 in Missoula, there was an average copper in the blood of osprey chicks of 3,073 microgram per liter. If we go down here and take a look at all of our other data points, you can see that they are not nearly as high. We have one here that was at Warm Springs at 502 microgram per liter. Wow, so this point at the same year, drastically higher. I wonder what happened. So another thing that I'm seeing is these two locations have very similar numbers in terms of what their copper values were in the osprey chicks. I wonder how that happened since, again, they're at very different locations along the Clark Fork River. And also, historically, we know that Warm Springs Pond was more heavily impacted by all the historical unregulated mining close to Butte. So this is really fascinating to me. Another tool that I want to just quickly show you guys that you can use when you're exploring your questions is going one step further and actually looking at some different mathematical functions. Let's say I want to isolate Warm Springs and just look at that data alone. So I'm going to click on Warm Springs, click the eye and hit hide unselected cases. And now I'm just working with Warm Springs. So if I want to create a line graph to get a different visual, I'm going to hit the ruler, which is underneath the eye, and hit connecting lines. And you can see that that forms a nice line graph for me. Another thing that would be interesting to do is to look at what's called a trend line. In this case, they've labeled it least squares line. All right, so that puts the best fit line with this data over time to show me how that data is operating from the years 2006 to 2019. I see there's a slight decrease, not very much, but that trend line is definitely going down a little bit. Just for curiosity, since we're here, let's see what zinc did at Warm Springs over time. Oh my gosh, super different. Wow. Okay, so zinc has this trend line, strong upward trend, increasing over time, where if we hit the undo button, you can undo anything at any time or redo. Here we are back with copper, a slight decrease. Very fascinating. It's also worth noting, you guys, you can always just start over. If I wanted to start over completely, I could just exit out of my graph and click graph function again and have a brand new clean slate to work with. So I'm going to restore my map. We just went through quite a few tools for you guys to learn how to explore this data in a very visual way and make sense of it. There are so many questions that you guys can have and hopefully are now thinking about after viewing how to use CODAP. I hope that this tutorial helped give you some tips and tricks to make sense of a data set. And now it's time for you all to explore.